Welcome back, everyone. So, we will continue with the other interfaces that we have not discussed in the previous video, which is important as well. So, for command line interface, we haven't discussed the brain computer. Brain computer interfaces provide a communication pathway between a person's brain waves and an external device such as cursor on a screen or tangible puck that moves via airflow. The person trained to concentrate on the task, for example, moving the cursor of the puck. Several research projects have investigated how this technique can be used to assist aug- and augment human cognitive sensor motor function. The way BCI works is by detecting changes in neural functioning of the brain. So it detects the function of your brain whenever you think, move, remember something, and feel. Small electrical signal rapidly move from neuron to neuron, which certain extent can be detected by electrodes that are placed on a person's scalp. The electrodes are embedded in specialized headset, helmets, or cups. Brain is a kind of BCI that have been developed to enable people who are paralyzed to control robots to be able to move a cursor on a computer screen display and letter on the alphabet. So this is all about controlling computer uh, by a paralyzed person for them to be able to write a sentence, communicate. So notice that it's all about computers on how it control the computers. So the challenges with this is that to what extent can this be applied because our thoughts are always been private. So what if it got mistaken with information on your head? It's not the right information. Or what if you don't want to share your thoughts, right? So to this end, we have developed a wearable headset that collects EEG data from one person's brain that they then label and categorize into various states before delivering into another person's brain via a form of brain stimulation. The brain states are categorized concentrating, focus, motor activity, stress, excited, relaxed, or bored. The goal is to see if they can literally transfer from one person's state of mind to someone else. So basically, they use EGG to detect your feelings, whether you're concentrating, focus, and then they're trying to transfer that to other person's mind. So here's an example video. So it's a paralyzed person. We'll just skip
Kind of brain
this
machine system, the assistive technology, clumsy robot, was to
here.
make it react to its
So here, it's trying to the robot are trying to serve the tumbler. Next, we'll go to graphical user interface. So we have not discussed um, augmented reality. So for augmented reality, it's like this: using a player's smartphone, camera, and GPS signal, the AR game makes it seem as if virtual Pokemon characters are appearing in the real world, popping up all over the place, such as on buildings, on streets, and in parks. As players walk around a given place, they may be greeted with rusting bits of grass that sign a Pokemon nearby. So I know you're aware of Pokemon Go, which was trending during the pandemic. So it used augmented reality to using smartphone camera and GPS signal. So if they walk closer, a Pokemon may pop up on their smartphone screen as if by magic and look as if they're actually in front of them. AR works by superimposing digital elements like Pokemon onto physical devices and objects. To begin, augmented reality was mostly a subject of experimentation with medicine, where virtual objects, for example, X-rays, and scans, were overload part of a patient's body to aid the physical understanding of what was being examined. or operated on. AR was then used to edit aid controllers and operators in rapid decision making. One example is air traffic control, where controllers are provided with dynamic information about the aircraft intersection that is overlaid on a video screen showing real planes landing, taking off, and taxiing. So it has been usually used for medicine, to track or to be substitute for X-ray and scans to the patient's body. And then it was subsequently used to aid air controllers, to do rapid decision making. So they are provided with dynamic information about the aircraft intersection that is overlaid on a video screen showing a real plane taking off and taxiing. So, as well as HUDs, augmented reality can be viewed through headsets, smartphones, and glasses, like Snapchat's AR spectacles. The most convenient device to use when viewing AR is smartphone. Headset can provide a more immersive experience, but the downside is they're cumbersome to wear and fiddly to calibrate. In the future, it's likely that more convenient and easy to wear AR glasses will be more popular and enable people both to create and to share their digital AR contents with the other. So here's an example of an AR. Let's watch. So basically, there is an AR that was created by Google. That AR is actually has a integrated development environment, kind of like uh, IDE for like Visual Studio for developers, that allow developers to be able to create an app using that tool, or using that easily. So it's like an Android developer studio that allows you to easily create an Android app. AR has that as well. AR-based instruction for building and repairing complex equipment such as photocopiers and fire engines have also been designed to replace paper-based manuals, where drawings are superimposed upon the machinery itself, telling the mechanic what to do and where to do it. There are also many AR apps available for a range context from education to car navigation, where digital content is overlaid on geographic location and objects. To reveal the digital information, users open the AR app on smartphone or tablet, and the content appears superimposed on what is being viewed through screen. So the easiest use of AR is on smartphones, right? Because you can easily use that. For a headset, it's kind of irritating. So another thing is in manufacturing. It can be used as well for the task that was be routinized or could be digitalized using AR, such as drawing of engines, etc. The availability of mapping platforms such as the provided Niantics and Google, together with Apple's AR Kit, Spark AR Studio, and Google AR Core, has made it easy for developers and students alike to develop new kinds of AR games and AR apps. Another popular AR game has emerged since the Pokemon Go as Jurassic World, a live where players walk around in the real world as many virtual dinosaurs they can. One of the limitations of current AR technology is that sometimes the modeling can be slightly off, that overlaying of the digital information appears in the wrong place or is out of sync with what is being laid. So sometimes it's out of sync because the current computer vision and machine learning algorithm is not perfect. So the model sometimes could not copy your face. But here's an example of an AR app that allows you to mimic a person in a dressing room. So a principal seen trying to on the virtual look of Akhenaten, and this second picture of an AR mirror in the ENO dressing room. So let's go on the physical interfaces, which we haven't discussed in the previous video. Haptic, the first interface is haptic. So haptic interfaces provide tactile feedback by applying vibration and forces to one person using actuators that are embedded in their clothing or device that they are carrying, such as smartphone or smartwatch. Gaming consoles have also employed vibrations to enrich experience. For example, car steering wheels that are used with driving simulators can vibrate in various ways to provide the feel of the road. Haptics are used in gaming consoles, smartphones, and controllers to alert or heighten a user experience. So basically, it's like vibration that puts in your body. So here's an example of its use to be able to position the instrument properly. So the haptic vibration will vibrate until you get the right position. Another is with games, or if you ever play in a toy or in a mall in a driving wheel, sometimes they vibrate to provide a real life vibration. So another form of feedback is ultra haptics, which creates the illusion of touch in midair. It does this by using ultrasound to make three-dimensional shapes and textures that can be felt but not seen by the user. This technique can be used to create the illusion of having buttons and sliders that appear in midair. One potential is in the automotive industry to replace existing physical buttons and knobs or touchscreen. So, an automotive industry, there's a lot of buttons, knobs, or touch screens. So this could replace that because it also includes 3D. So as you can see, guys, this haptic interface also include 3D, which is kind of like a hologram, which we will discuss in the later part of the video. But they intersected. So this ultra haptics is an example of that. It's like an illusion of touch in midair that provides this vibration feeling or real life feeling. So Jonathan Ross and his team in 2018 developed a new kind of exoskeleton that can help people stand and move around using these artificial muscles that consist of air bubbles that act as a haptic feedback that are activated using tiny electric motors. They are stiffened or relaxed using graph them e-parts to make the trousers move. One application area is to help people who have walking difficulties and those who need to exercise but it's difficult to do so. So here is an example of a trousers that has been developed to help people exercise. So it's a exoskeleton like help people stand, move around using artificial muscles that vibrate. Consists of air bubbles that vibrate around their body to be able to motivate them. So, uh, for example, the patterns of vibration have been placed across snowboarders' bodies to indicate which moves to take while snowboarding. A study report faster reaction times when the same instruction were given in 2009. So this has been being experimented since 2009, even in snowboarders. It helps them to be able to dictate which modes to take. And then tangible. So there is an example of a kid using a tangible interface to help him learn coding. Tangible interface use screen or use sensor-based interaction where physical objects such as bricks, balls, and cubes are coupled with digital representation in 1997. When a person manipulates the physical objects, it is detected by a computer system via the sensing mechanism embedded in the physical object, causing in digital effect to occur such as sound, animation, or vibration. The digital effects can take place in a number of media and places, or they can be embedded in physical object itself. Tangible interface differ from other approaches such as mobile, in so far as the representation are artifacts in their own right, that they can be directly acted upon, rearranged, sorted, and manipulated. So again, these are being represented in different types of media, but primarily digital media, because The main idea you're trying to digitalize the interaction. It could use sounds, graphics, and then vibration. So it used an embedded sensor inside this device to be able to control the digital screen. The technology that have been used to create tangibles include RFID tags and sensors embedded in physical objects and digital tabletops that sense the movement of objects and subsequently provide visualizations surrounding the physical objects. Many tangible systems have been built with the goal of encouraging learning, design activities, playfulness, and collaboration. These include planning tools for landscape and urban planning, which was developed by scientists in 2005. So it's all about also encouraging the learning, the design activities, and the playfulness, and it has been applied in urban planning and for landscaping of an actual building since 2005. Physical objects can also be held in both hands and combined and manipulated in ways not possible using other interfaces. This allows for more than one person to explore the interface together and for objects to be placed on top of each other, besides each other, inside each other. The different configuration encourage different ways of representing and exploring problems. In so doing, people are able to see and understand situations differently, which can lead to greater insight, learning, and problem solving with other kinds of interfaces. So again, it's about using the right tools to be able for you to make sense of the ongoing activity. That ongoing activity, because you're trying to use the tool to do the thing that you want to do faster than you would have using other tools. So I hope you're getting my point of about these interfaces on why it is useful. Because later we will discuss that as well. It was designed as a largely physical system that provides a range of tangible input mechanisms through which people give their opinion instead of using, for example, text messages or social media input. The various input mechanisms include sliders, button knobs, and spinners about which people are familiar. In addition, the system has transparent tube on the sign that drops a ball step by step set of questions are completed to act as an incentive for completion as a progressive indicator. The result of the selectors were aggregated and presented as a digital visualization. So basically, these are an example of a large physical system that converts the digital representation to a physical tool. So it's kind of like reverse because instead of trying to augment the factory operation of button knobs to a 3D, you're trying to make it physical. You're trying to add button knobs and spinners for people to feel. So another research is on the following: which type of digital output should tangible interfaces be combined, overlaying in physical objects with graphical feedback that change in response to how the objects manipulated has been the main approach. In addition, audio and haptic feedback has been used. Tangibles can also be designed to be an integral part of multimodal interface. So here's an example of that where the questionnaire, instead of just pen and paper or instead of just tablet, they make it more physical by adding knobs, button, and spinners. So these are again usually integrated, could be integrated with multimodal interface, which we have discussed, which we have discussed later. So it could be an additional feature for the user. Shareable. So shareable, we have discussed this in the collaboration part, but we will discuss this interface as well. Here's an example of a shareable screen and a shareable game. Shareable interface typically provide multiple inputs and sometimes allow simultaneous inputs like co-located groups. This include large wall displays, for example, smartboard, and interactive tabletops, where small groups can interact with information being displayed on the surface using the fingertips. An early example of an interactive tabletop was Circle 12's Diamond Touch in 2001. An array of antenna was embedded into the touch surface and each one transmitted unique signal. So the early example is in 2001, and then there's an embedded antenna on that tabletop. So this has been uh, being experimented since 2001. Each person had their own receiver embedded in a mat on which they were standing or a chair in which they were sitting. When they touched the tabletop, very small signals sent through their body to a receiver that identified which antenna has been touched and sent this to the customer. Multiple people could interact simultaneously with the digital content using their fingertips. Sadly, the technology is no longer available, but a video of how it works is available. Various commercial products now exist to enable multiple remote people to work on the same document at the same time, such as Google Docs and Microsoft Excel, sometimes enable up to 50 people to edit the same document at the same time with more watching on. These software programs provide various functions, such as asynchronous editing, tracking changes, annotating, and commenting, but the early example of this was a shared editing tools in 1980. So the early example is an editing tool in 1980, but now we don't notice, but the Excel that we use in our work is also a part of this shareable interface. Several research have designed cross-device systems where a variety of devices such as tablets, smartphone, and digital pens can be used in conjunction with the shareable surface. For example, Surface Constellations was developed for linking mobile device to create novel cross-device workspace environment in 2018. Design guidelines and summaries of empirical research on tabletops and multi-touch device can be found in Mueller 2010. So let's go to wearables. So wearables are a broad category of devices that are worn on the body. This includes smartwatches, fitness trackers, fashion tech, and smart glasses. Since the early experimental days of wearable computing, where Steve Mann, 1997, donned head and eye cameras to enable him to record what he saw while also accessing digital information on the move. There have been many innovations and inventions. So it was started in 1997 with someone imagining that using their head and eye cameras that will enable them to record what they are doing while accessing digital information on the move. So this is the key idea of wearable. You can access the digital information while you are walking, running, doing your laundry, etc. More recent applications shape focus on how to combine textiles, electronics, and haptic technologies to promote new forms of communications. For example, Cute Circuit developed the kinetic dress, which is embedded with sensors that follow the body of wearers to capture their movements and interaction with others. These were displayed through electroluminescent embroidery that can cover the external skirt section of the dress. Depending on the amount and speed of the weather movement, it changed patterns, displaying the weather mode to the audience and creating halo, a magic halo around her. So basically, it combines the haptic as well, the vibration. So that's why these are included in physical interface because you're moving. So depending on the wearer's movement, the LED on his body is changing. So that's another application of this. It's on the dress that you wear. Exoskeleton clothing is also an area where fashion meets technology. In order to augment and assist people who have problems with walking by literally walking, exercising the person wearing them. In this way, it combines haptics with wearable. Within the construction industry, exoskeleton suits have also been developed to provide additional power to workers, a bit like Superman, where metal frameworks are fitted with motorized muscles to multiply the wearer's strengths. So it is used in construction as well, where metal frameworks is fitted with the motorized muscles to amplify the muscles of the wearer and then lift up more bricks. It can make lifting objects feel lighter and, in doing so, protect the workers from physical injuries. Another thing is it also helps the person walking, kind of like in the tan- uh, tactile. Ah, I forgot. Let me check. Kind of like in the haptic vibration. Another, it was designed to look like a pair of glass, but this is a Google Glass that was designed to be a pair of glass, but with one lens of the glass being an interactive display. So one has a display embedded camera that could be controlled with speech input. It allowed wearer to take photos and videos on the move and look at digital content such as email, text, and maps. So on one eye, it allowed to manipulate digital content such as email, text, and maps. A number of applications were developed beyond those for everyday use, including Watch Me Talk, which provide live captions to help the hearing impaired in their day-to-day conversations, and Preview for Glass that enable the wearer to watch a movie trailer the moment they look at movie poster. So when this was created in 2014, an application that has or provide live caption as are invented. But unfortunately, this has been discontinued after a few years because it's not as useful for everyday life. So visually, a movie that when they look a movie, it will show the trailer. So that app as well. It was developed by third party aside from the everyday apps like maps, email, or text. So a number of technologies can be developed and combined to create wearables, including LEDs, sensors, actuators, tangibles, and AR. So AR, which include in graphics, could also include here in wearables. So here's an example of a talking shoe, which did not uh, was not an invention that did not were not adopted. So here, here's the shoe. It talks actually here.
Love the feeling of wind in my laces.
So robots and drones. Robots have been around for some time, most notably as characters in science fiction, but they also play an important role as part of manufacturing assembly lines as remote investigators of hazardous location. For example, nuclear power stations and bomb disposal, and as search and rescue helpers in disasters. For instance, in forests or faraway places like Mars, console interfaces have been developed to enable humans to control and navigate robots in remote terrains using combination of joysticks and keyboard and controls together with cameras and sensor-based interaction. So remote control has been designed to control this robot to go to places where we would that human would not be possible. like Mars. So it has been first described in science fiction, but now being used in manufacturing assembly as well. So here's an example of pet hosting a show, and then as a pet acting as a caregiver or entertainer for old people. So nothing much to say about this because I know you're familiar with this. Let's go to drones. Drones are a form of unmanned aircraft that are controlled remotely. They were first used by hobbyists and then by military. This includes entertainment such as carrying drinks, food to people, festival, and parties. More recently, they have been used to drop medical supplies and all manners of groceries, from coffees to melons. People can order something on their phone, and within minutes, a parcel released and lowered on uh, a dangling piece of string in front of their warehouse. But let's check this actually a video of a robot. Here is so there could be a robot for vacuum. So the key concern as well for a robot is that uh, would it be acceptable to make them like humans that do everything, or just for a specific task like that vacuum cleaner? So here is an example of a drone taking videos of plants and then trying to check if they could be harvested. Another use of that is for groceries, and then etc. So should robots be designed to be as human-like or possible, looking like us with human features such as eyes and mouth, behaving like us, communicating like us, emotionally responding like us, or should they be designed to look like robots and behave like robots, for instance, vacuum cleaner, right? Likewise, should the interaction be designed to enable people to interact with robots as it were another human being. For example, talking to it, gesturing to it, holding its hand, and smiling at it. Or should the interaction designed to be more like human computer interaction, in other words, pressing buttons, knobs, and dials to issue command? So, lastly, last part of shape physical interface is shape changing. Shape changing interfaces employ physical shape change as input to systems. A well known example. Uh, So here, I think I got this in the wrong. Yeah, I got this in the wrong. Oh my God. So uh, input change as input and output to system as well known as a physical 3D bar chart. So here is an example of a physical 3D bar chart. Basically, it can change the shape based on the data. Basically, it's trying to make sense of the information fast. You're trying to use the right tool. So there's some use cases for this. For example, to be able to easily visualize a graph. You can also annotate this. Other examples of shape-changing interface include data sculptures, tactile cartographic maps, and physicalizations. So another is a sculpture where you can uh, sculpt what you want. For example, the physical cubes are intended to be located in home settings such as the living room, which helps with the interpretation of data. Imagine a group of people sitting in a living room. So let's say a group of people is sitting in a living room, and you want to visualize the oxygen or CO2 on how bad it is, then physical shape or this shape changing could be useful because once you see that it's oxygen problem, then it might not be you problem. It might not be a movie problem that the reason you are bored with what you are watching. So actually, this picture is the 3D. So it was just added in Multimedia. So just disregard that. So let's continue with the last part, multimodal or emerging interfaces. So we have discussed the multimedia, but we haven't discussed the multimodal. Multimodal interfaces are intended to enrich user experience by multiplying the way information is experienced and controlled at the interface through using different modalities such as touch, sight, sound, and speech. Interface techniques that have been combined for this purpose include speech and gesture, eye gaze and gesture, haptic and audio output, and pen input and speech. The assumption is that multimodal interfaces can support more flexible, efficient, and expressive means of human-computer interaction that are more akin to multimodal experiences that humans encounter in the physical world. So you have the pen. So basically, all of the interfaces could be included in multimodal interfaces. You're trying to mimic the human interaction or the physical world, but the question is, does mimicking or does adding multiple interfaces does really add or make it better with the ongoing task, or it just makes complex because you have to learn the complex system longer, right? So that's the challenge with this multimodal. Different inputs or outputs may be used at the same time. For example, using voice commands and gestures simultaneously to move a virtual environment, or alternatively using speech commands to followed by gesturing. The most common combination of technologies used for multimodal interfaces is speech and vision processing. Multimodal interfaces can also be combined with multi-sensor input to enable other aspects of human body to be tracked. So the most common use for this is a voice recognition and uh, a speech recognition and visual uh, recognition and a sensing of your body like this. It sense your body and then it see you and it hear you. So it's a Microsoft's XDoc Kinect, kind of similar with the touchless being used in the surgery room. On finding, also the name as well. Here it has Xbox, but with the surgery, it's only Kinect. On finding a body, the Kinect locked into it and measured the three-dimensional positioning of the regions in their body. This information was converted into graphical avatar of the user that could be programmed to move just like them. So here, the information was converted into this graphical or digital representation, and it could be programmed to move just like them. So this has a software that programmed to move like this, whatever things that it detects. So additional thing is for visuals or visual parsing, the most common camera used is RGB. So take note of that, guys, RGB camera. So this probably are using RGB, and in many ways, this is much harder to accomplish and calibrate than single modality systems that are programmed to recognize one aspect of a user behavior. The most researched modes of interactions are speech, gesture, and eye gazing, gaze tracking. A key research question is what is actually gained from combining different inputs and outputs, whether talking and gesturing humans do with other humans is a natural way with of interacting with computer. So the most research for this are speed, gestures, which is the touchless, and the eye gaze tracking. Because those remember eye gestures and the speech. So remember the most useful part of this because in a lot of the ways that's also the most useful part of our body, our speech, our eye gaze, and our gestures, right? Because that's how we communicate. Smart interfaces. So the smartphone is an example of smart interfaces, but this adjective is often used to suggest that the device has some intelligence and is connected to the internet. More generally, smart devices are designed to interact with other devices connected to a network, many of which are automated. The goal is to make them context aware, that is, to understand what is happening around them and execute appropriate actions. To achieve this, some have been programmed with AI so that they can learn the context and a person's behavior. So basically, this smart is connected to other devices on the internet. And the idea is to be able to have that one smart tool to be context aware with the other devices on the network. Uh, Sometimes these devices could use an AI. So your smartphone is smart because they can use your AI to be able to make sense of your questions. In terms of research consideration, he argues that he will need new metaphors to understanding and using smart interface easier. Uses desktop, Windows, icon, metaphors, leads for the GUI. What might this be? Should they likewise be based on everyday objects and activities, or should they be more aligned with human qualities, giving robot particular personality types such as extrovert, introvert, can be engaging and make them more appealing to people. So a lot of smart devices were created. Another example is this a smart building. So another field is a human to building interaction where they study on how far the building should be smart. Like the key challenge is sometimes the building has a lot of cameras because this smart system make a lot of things autonomous, but at the same time, it also allow them to track a lot of information about us. So that's a key challenge here. But this for the future research is suggesting to use metaphor like a robot that is introvert or extrovert, a smart robot that has a metaphor to our everyday life could be more natural, just like GUI did with their interface with the folder as an icon. So, and lastly, for the multimodal interface is the holographic. So, holographic interface try to create the illusion of a 3D person being present through taking advantage of the human perceptual system. Advantage in projection and display technology have enabled this kind of digital representations to appear quite convincing. The technology used include 365 million pixel screens, massive flat display, and make the image projected as if they were real, and motion capture technology. So take note of this. It was enabled by motion capture technology and 365 million pixel screen. So imagine that, guys. These screens is what allow this 3D or real life representation of digital information. Here's an example of that in ABBA's concert. So basically, it's taking advantage as well of our human perception system. It's like tricking your brain to think that it's a 3D. So this is a latest example of Mark Zuckerberg in 3D using a holographic AR glass. So there is currently much research being conducted in the tech industry exploring what is the best way to represent people in virtual spaces so they feel comfortable, are engaging to interact with, feel natural, and do not appear creepy. Design consideration including what size of photographs should be and how people viewing them can interact and communicate with them being projected into the space. So these are the latest technology and currently being researched. Research is how small the design could be, or what size of the holographic should be. For example, for this eyeglass, actually it's just an eyeglass. These are just like an eyeglass that is less than 100 grams. But as Mark Zuckerberg said, they're trying to design smaller eyeglass for it to be a consumer product. Now, what's the catch with all of this? So, another thing is actually natural. Last thing is the natural interface, which is like mimicking our natural way of doing things, such as talking, what humans do on a daily basis. It's like trying to mimic that interface for it to be feel natural. Now, NUIs combine multiple modalities: visual, auditory, gestural, bodily, and they are defined by how naturally they map to human behavior, not by a single input channel. The staple for many years was the GUI, then the mobile device interface, followed by touch and now wearables and smart interfaces. In the near future, we could see more holographic interfaces. Without question, they have been able to support all manner of user activities. A natural user interface is designed to allow people to interact with a computer in the same way that they interact with the physical world, using their voice, hands, and bodies instead of using keyboard, mouse, or touchpad, as is the case with GUIs. NUIs enable users to speak to machines, stroke their surfaces, gestures at them in the air, and smile at them to get a reaction, and so on. The naturalness refers to the use of everyday human skills humans have developed and learned, such as talking, typing, gesturing, walking, and picking objects. So it's kind of like a robot, new generation of robot, where you can talk, uh, you can gesture, you can pick up objects, you can walk to communicate your thoughts. So Enya argues that whether Enya is a natural depends on a number of factors, including how much learning is required, the complexity of the app or device's interface, and whether the accuracy and speed are needed. Sometimes a gesture is worth a thousand words. Otherwise, a word is worth a thousand gestures. It depends on how many functions the system supports. So again, like what I've said with the word repeating word could mean a thousand gestures, and a gesture worth a thousand words. Basically, it depends on the activity that you're trying to make sense. Because does it really make sense for you to create a robot for a simple task like boiling your water? It may not, right? Because those are expensive, and as well it is complicated, more complicated to build, and then more expensive. So it depends. It also needs a lot of um, complex learning before you understand that system, right? Because a simple boiling pot could be hard for some people to understand. What's more these complex tools. So, but if they put their hand under the tap, might that have the effect of decreasing the flow? Another example is for a faucet. So like a sensor faucet, sometimes when you raise your hand, the faucet do not detect it. Sometimes it misrepresent your walking to opening the faucet. You don't really like to open the faucet, but it automatically open it. So those circumstances are not natural. Uh, in this case. So would it require having both arms suspended in mid-air for a few seconds to register that was the desired state? It's a difficult problem on how to provide these choices, and it's probably why sensor-based faucets in public bathrooms have their temperature and flow set to default. So there's saying in code like no code is the best code because the more you add code, the more you add complexity. So you have to consider that as well. Adding AI to the mix has also enabled new types of interface to emerge to go beyond simply being natural and smart. Ones that allow people to work synergistically with technology to solve ever more complex problems, undertake unimaginable feats. Moreover, being able to purchase regular phone means not being singled out for special treatment. And while some gestures feel cumbersome for sighted people to learn and use, they may not be for blind or visually impaired people. Another thing here is that we are different, so what natural for others could not be natural for others. For example, I studied computer science, so I'm well versed with this technology. So I understand how this works. So I have a lot of advantage when it comes to computers. But for others, they may not know and they may not be willing to spend a lot of time learning this. So they, you could provide different interface for that. I could create an app using a code from scratch, like a programming language. Others, they may just need a website like WordPress, where they can just drag and drop to create their website. So it's different for natural is different for different people. The iPhone was over press guest feature that reads out what you tap on the screen. For example, messages, calendars, mail, find new items can open up new ways of exploring an application, while a three-finger tap can become a natural way to turn the screen off. Now, which interface is best? Which is the last topic. Let's continue that further. Um, how to decide which interface is preferable for a given task. Just hold on for a moment. All right. So, how to decide? So basically, for deciding, it depends on the activity that you want, because like what I've said, different activity uh, is uh, has different natural interface, and it depends on the people's doing it. But is multimedia better than tangible interfaces for learning? Is voice effective as a command-based interface? Is multimodal interface more effective than a single media interface? Are wearable interface better than mobile interfaces for helping people find information in foreign cities? How does VR differ from AR? And which is the ultimate interface for playing games? In what way are tangible environments more challenging and captivating than virtual worlds? And so forth. In practice, which interface is most appropriate, most useful, most efficient, most engaging, most supported, and so on will depend on the interplay of a number of factors, including type of task, people using the system, context, reliability, social acceptability, privacy, ethical, and location concerns. So the thing here is that for me, for example, for appliances, I prefer the non-tech or non-LCD based appliances because I know that that could break faster, and I know myself that I easily break things. So what I do is I bought appliances that are simple, old, but I can understand well because I know that when it breaks, I can repair it, which eventually will. And I know that there is like a right to repair concept that uh, companies use to kind of like break the middle class or something like that. So that's my point of view. Also, for ethical concerns, I'm not worried about entering my details because I know that for a lot of this website, it's about cognitive load. So no one's really trying to hack you unless you're like super famous and you post a lot on Facebook or in social media. So it really depends because I know a lot about security. So I'm only concerned for the security of the bank of my bank, and I know that if fraudster is not do not know did not have my phone number, then I'm all good. So as long as I then still have my SIM card, I know that no one will get the money on my back. So those are the type of things, but for other people, they may not be aware. The thing here is that if you don't know about the technology, there is a black box. So you could imagine anything that could happen. You could imagine like some rocket uh, will will fire at your back or something, or some like um, drone technology will kill you, but it's not, because our physical things are limited. People are busy. You have to determine about that. So this is what it meant by that. And again, guys, thank you. We were able to discuss all of the interface. So this is super useful in our everyday life. That's why I created the content and I made an effort, including the videos, as you have suggested. So this will help us to do our task better because we will be able to know what's the available interface or tools to do our task. And again, thank you for watching. See you on the next video. Peace.